Here at my company, Total Seminars, you can separate everybody into one of two groups. There's the cool, amazing nerds like me, and there's the Mac users. I'm looking around my entire studio, I'm filled with Mac users right now. But in all honesty, I'm kidding. I actually do enjoy using Macs quite a bit. As you can tell, we do videos, and for video development, it's an extremely popular platform. Macs have been around now for over 30 years. They've never had nearly the adoption that Windows has, but their small group, which hovers usually around 10% of all desktop users, is a vehement group and are very, very proud of their platform. So what I want to do in this episode is do a quick little tour of the Mac OS and give you an idea of some of the functions and features that it has. Now keep in mind, we're really concentrating on the desktop, and we're looking at this from the attitude of a Windows user being exposed to the Mac OS. So let's take a quick peek. This is a pretty standard Mac OS desktop. Now, what I want to start off with is let's take a look up at the top. So in the upper left-hand corner here, what we have, we call this the Apple menu. And we're going to see that this menu changes depending on what application is active at any given moment. Now, on the far right-hand side over here, we call this the status menu. And this basically just keeps track, how's my wireless doing, date, time. I can light up Siri if I want to. So basically, just gives us an idea of what's taking place on the system at any given moment. Now, probably the most interesting part to the Mac OS is down here. We call this the dock. So this is the programs that I like to use the most that I place here on the dock, and I have them up and ready to run if I need to use them. So let's go ahead and just pick one here arbitrarily. Here's an interesting little note reminder program. So I'm going to fire this up. Oh, and by the way, Windows people, it's single click in Macland, not double click like we do in Windows. So here I've got this one application up. Now, as you look at this, look in the upper left-hand corner. So you'll notice that this Apple menu changes depending on the context of whatever application I have up and running at any given moment. So I can click like right here on the desktop, and you'll see this changes into a Finder, which we'll talk about in just a moment. So you run your applications, and like Windows apps, you have maximize, minimize, close. So I can minimize this if I want, and you can see it's sitting over here. I can bring it back up. I can maximize it, although I'm not sure what it's going to look like with this guy. Yeah, okay, maybe not the best example, but it works. So I just click that green button again and bring it back into a window. And then if I want to close it, I hit the X. Now, in this particular case, you'll see that it actually closed. Let's do this again, and this time I'm going to try the calendar. Now, if you look at the calendar, it's pretty small, but you can see that little dot right there. That tells me that that program's running. So a lot of programs, if you hit the red X, you see the black dot still there? That's telling me that the program's actually still running. So I'm going to bring this back up, and to actually turn it off, we're going to hit the command button. Hey, let's put up an example of what a command button looks like. So it looks like this, and I'm just going to hit Command Q, and that is the big way that we quit applications within the Mac OS environment. Okay, so just to show you a couple other little things, one of the big things we like to use is a Finder. So if you're used to File Explorer in Windows, you're going to like a Finder. So we can bring it up right here, but usually the place to bring it up is we'll see this little smiley face down here. And we bring this up, and this is going to show me the folder contents on my particular system. So for example, if I want to see what applications are installed, I can go through here and under the applications, and we can see all the installed applications, as well as stuff, for example, there's a documents folder, which is similar to a documents folder in Windows, and a desktop folder, which again, pretty much identical in terms of functionality to the desktop folders within a Windows environment. All right. Now, if you want to work with system preferences, there is a tool right here, which is pretty much the same name we use in Linux, System Preferences. And this would be the closest equivalent to the control panel or settings that we see in a Windows environment. So here, if I want to configure a mouse or work with my display resolution, whatever I might want to do, this is all going to be handled within System Preferences. Now, for decades, the Mac operating system never had a command prompt. So in Linux, we've always had a command prompt. In Windows, we have a command prompt. But for many decades in the Mac environment, there was no command line. I couldn't get to a terminal. But about a little over 10 years ago, they changed that. And today, we do have a terminal in the classic sense of the word. So if you take a look right here, so here is a terminal that I'm running, and I can type in commands. By the way, I don't know if you were watching earlier, but that ls command, it's the same command that I typed in Linux, right? That's because today's Mac OS is actually based on the precursor to Linux called Unix. So if you know how to use a terminal on a Linux system, you can pretty much use a terminal on a Mac as well. So that makes a lot of Linux/Unix people really like the Mac quite a bit because of that commonality. So this is a very, very quick tour of the Mac OS. Now we're going to be coming back to it in other episodes, but for right now what I want to make sure you're comfortable with are some of the terminologies we use, and especially if you're a Windows person, Macs really aren't a bad way to go at all. There's an operating system out there that you may not be aware of known as Linux. Linux is an operating system that's been around for over 20 years now, and it's really over in the last few years really coming into its own. The problem with Linux is that, first of all, this is not Windows. This is not Mac OS. It's its own thing. You don't see Linux on desktops very often. You don't see Linux on laptop computers very often. But where you do see Linux is in, like, for example, this Netgear router actually runs on this Linux operating system. Here I have a little microcomputer called a Raspberry Pi. It runs on Linux. Even my Android phone uses a variation of Linux designed by Google. So Linux is absolutely everywhere, and Linux has some big benefits. Number one, here's the biggest. Linux is absolutely free. So you just grab a copy and you do whatever you want. Now there's some complexities here. Number one, when we say the word Linux, what we're talking about is just the kernel of the operating system. Along with the kernel of the operating system are desktop interfaces and device drivers for network cards and controllers for hard drives and all this stuff. Linux is just the controller. Along with Linux are hundreds of thousands of different programs that are under the GNU license. GNU always stands for GNU's not Unix, but here's the official name for what GNU stands for. The GNU license basically means I, as a programmer, want to write a program that allows me to allow Linux kernel to talk to a hard drive. So I'd write one up. Yes, there are people who do this all over the world. They do it for free, and thank goodness they do. Or I might be a programmer who decides to write up a new desktop interface. See, that's the other cool thing about Linux. With Windows, you have the Windows desktop. With Mac OS, you have the Mac OS desktop. But with Linux, you can pick almost any desktop you want. So this creates a problem. The problem is that anybody who wants to, they can, as long as they have to take the Linux kernel, but then they could put this desktop on here, and this type of hard drive controller, and this thing to install the program, and this is their own store, so you can download their programs. And you could put all this together in a big bundle, and we call that a Linux distribution or a Linux distro. There are thousands, I mean thousands of Linux distros that are out there today. And what we're going to do in this episode is we're going to talk about one very specific and extremely popular one called Ubuntu. Ubuntu has been around for a while, and it is one of the best versions of Linux. If you want to replace Windows, this is the one that you would turn to. Now, before we dive into that too much, I want to show you a couple of other distributions. People often will pick the distro of Linux they like, often because they just like the interface, or they have a specific function. Like, for example, if you get a Raspberry, it has a very specific distro called Raspbian, which is designed just for this. Other folks, like Netgear, they'll pick and choose, and they'll develop their own distro just for their specific devices. So let's take a couple peeks at some other distros, mainly because there's some really cool interfaces out there. So the first thing I'd like to start off with is a very, very popular fellow called Fedora. So this is the default Fedora interface. Fedora has been around, in fact, arguably, Fedora has been around longer than just about anybody else. When we take a look at Fedora, we are looking at an interface known as KDE. KDE is very, very popular, and a lot of people like it. The only real alternative to KDE is GNOME. So GNOME is used on this Ubuntu. Let's take a look at another Linux system that's basically configured almost the exact same way, just with a different desktop. Here is Ubuntu. So we see it's got a nice little desktop kind of look. And at first peek, you might go, well, Mike, this looks almost identical. Well, you can almost change the interface to do anything you want. So people get very, very picky about which one they want. For example, if I write a solitaire game, I'm probably going to have to write it for either KDE or GNOME. So there's a lot of competition between those two interfaces. But there's one more I want to show because a lot of people like Windows quite a bit. So there's another very, very popular interface called Cinnamon. Let me show you that. Take a look at this interface. Does that look kind of familiar? It looks like we got a little start button. We've got start menus here. We've got the taskbar at the bottom. Kind of makes you think about Windows a little bit, doesn't it? So this is called Linux Mint, is the name of the distribution, and the desktop interface we're seeing here is called Cinnamon. This is really designed because a lot of people wanted the look and feel of Windows, and they felt that they could bring that into a Linux environment. Bottom line is that you're going to pick your own distribution for what you want to do. Now keep in mind, in this particular situation, we're talking about a desktop. So what I want to do right now is let's go back into Ubuntu and just talk about some of the parts of a standard desktop interface that you'll see pretty much on any Linux system, but in this case, Ubuntu. So as we take a look at Ubuntu here, probably the first place you're going to notice is we've got our top bar up here. So there's no taskbar like we have in a Windows environment, but we can do a lot of important things. For example, network can be handled up here. If we need to sign out or shut the system down, we can handle that here. Over here is what we call the dash, which is about as close to a taskbar as you're going to get in a Linux environment. So I like the name dash, you know, it's like kind of like it's dashboard, but whatever. Anyway, that's about as close as you're going to get to the Windows taskbar within a Linux environment. So the next thing I want to show you is activities. So if I click on this activities, you'll see that I can bring up multiple desktops in essence. So here, I don't know, I pull up a software function, maybe there's some software. I can click on activities here and I can actually jump back and forth between different desktops, which is awfully handy. Now the last thing I want to show you on the graphical interface is right here. So these are all the applications that are installed on this particular system. So anything that's installed is going to show up here. So in particular, one I want to show you, and this is the last thing I want to show you here, is Terminal. In a Linux environment, virtually everything that's critical is done from what we call a command prompt. So I have entire episodes that talk about a command prompt, but since we're in Linux, I want to at least make a mention of, and by the way, when I say command prompt, terminal, or shell, I use those terms interchangeably. To me, they mean the same thing that we're looking at right here on the screen. So I can type in strange commands and do all kinds of interesting stuff. Linux is an incredibly powerful tool. I use Linux to power all kinds of strange things in my house. For example, I've got a garage door opener that's running on one of these Raspbians that uses Linux so that I can open my garage door from my phone. Linux does not have a lot of penetration in the desktop, simply because Windows and Mac OS are so incredibly popular. But they are out there, they're pretty cool, and best of all, they're absolutely free. You know, it's always fun to look at the bottom of a CPU. It's got so many little wires or little pad contacts. There's, on modern CPUs, could be over 2,000 of these little connectors. And you always wonder, why does it need so many connectors? Based on other episodes, we've learned stuff like there's an external data bus, which is going to be, in our examples, we only used 8 wires. And I'm sure one of these is probably a clock wire, and a few of these are probably voltage, and a few of these are ground. But why so many wires? Well, I'm going to add to the list here a little bit and talk about something very important. We know that the CPU has to grab lines of code from RAM. The question is how does it do it? It's actually really fascinating. Let me show you. So here's my CPU. Now the CPU has an external data bus. In this case, I'm just going to say it's an 8-bit external data bus. They're a lot bigger today, but this will get us started. Now that external data bus doesn't just come out of the CPU and end. It extends throughout our computer. In fact, that's the job of a motherboard. Its job is to allow lots of different peripherals, hard drives and things like RAM, to also connect to the CPU. So let's take a look for a moment and let's take a look at some RAM. Now in the real world, RAM looks like a stick like this. However, electronically, RAM looks very different. RAM looks like a 1-column spreadsheet. In each column of this spreadsheet, you can store 8 binary values, or a byte. So the number of different rows we have in here is going to depend on something which I'm about to explain to you. So the challenge we have here is I've got this CPU over here, and I've got all of these lines of code. How can I get individual lines of code onto the CPU so that it can run it and do whatever it needs to do? Well, to do that, we're going to add another chip. This chip is known as the memory controller chip. Now, memory controller chips used to be a separate chip. However, today they're pretty much all built into the CPU itself. But for right now, let's just go ahead and keep him as a separate chip, and we're going to give him 8 wires to connect to the external data bus as well. All right, now once we've got this, the memory controller chip, in essence, kind of has a claw built into it. And this claw can grab any single byte of memory and put it on the external data bus, and then it gets sent to the CPU, and then the CPU can execute it. Sounds great, right? So the problem we have here is, how can the CPU tell the memory controller chip which one of these rows, which byte of RAM does it need to be dropped onto the external data bus so it can execute it? Well, the secret is something called an address bus. An address bus is a direct connection between the CPU and the memory controller chip that isn't used to move data. It's simply used by the CPU to tell the MCC which byte of memory it needs right now. If we want to understand how an address bus works, we need to think in terms of binary. So let's pretend like I have 1 wire running from the CPU to the memory controller chip in this new address bus thing I just mentioned. That wire can be in one of 2 states. It can be either off or on, right? So what we could say is that with a 1-bit address bus, we could address up to 2 different bytes of RAM. We could have 2 separate commands. And if it was off, it would grab the top one, and if it was on, we'd grab the second one. So that wouldn't be very useful if we only had 2 bytes of RAM in a computer, so we probably need a few more wires, right? Well, let's add a few more and watch what happens. Okay, in this particular example, what I'm going to do is I'm going to run 16 wires from the CPU to the memory controller chip. These 16 wires are not used to move data. They're just for the CPU to talk to the memory controller chip to tell it which row of memory it wants to access at any given moment. So if it's all turned off, that's 16 zeros, that's going to be the first byte of memory. And if they're all turned on, that's 16 ones, that's going to be the last one. So what we have here is 2 to the 16th power, or 65,536 bytes of RAM. Now that may not sound like much, but back in the day of the 16-bit address bus, that was crazy. So simply by putting different patterns of 1s and 0s on the address bus, the CPU can order the memory controller chip to grab individual rows of RAM so that we can run the program. Now 16-bit didn't last too terribly long. For a long time we had 32-bit address buses, and today we have 64-bit address buses. So a 32-bit address bus can address around 4 gigabytes of RAM, and a 64-bit address bus that's a huge here. Just put it up there. If you have 32 wires on an address bus, that means you can address 2 to the 32nd power, or about 4 gigabytes of RAM. Now, 32-bit addressing worked great from from the mid-'80s up until around the early 2000s. So 32-bit was extremely popular. However, if you talk to people today about how much RAM they have in their computer, you're going to hear people say things like, well, I got 8 gigabytes of RAM or 16 gigabytes of RAM. With 64-bit processors, we can address a lot more memory. If you put, say, 8 gigabytes of RAM in a system with a 32-bit CPU, it will only see 4 gigabytes. It'll never use more than that. It doesn't have enough wires, so it's just not going to happen. So the whole 32-bit versus 64-bit world is, well, it's not as big of a deal as it used to be because 64-bit has become so common. There's a couple of things I want to mention first of all. Number one, almost every 64-bit CPU on Earth can run 32-bit stuff if needed. It would prefer 64, but it can run 32. So that's an important thing to keep in mind. When in doubt, you're probably going to have a 64-bit processor. In terms of desktop CPUs, I haven't seen a dedicated 32-bit processor in many, many years. But we do mention this on the exam, so I want to cover it. So one of the things I want to show you is if you're going to have a 32-bit or a 64-bit processor, you're going to have to install the correct operating system to make that work. So I've got laid out here some installation media that I'd like you to take a look at, and it literally will show you whether it's a 64-bit or a 32-bit version of Windows. Let me show you what I mean. What I've got here is a number of different versions of Windows. I've got an old copy of Vista here. This is Windows 10. Down here is Windows 8.1. What I want you to notice more than anything else, see, this is a 64-bit version of Windows. This is a 32-bit version of Windows. This is a 64-bit version of Windows. So for years, you had to be really careful. If you had a 64-bit processor, you made sure to get a 64-bit copy of Windows. If you had a 32-bit processor, you got a 32-bit copy of Windows. Modern installation media will literally query your system, and if it's a 64-bit processor, it'll install 64-bit. If it's a 32-bit processor, it'll install 32-bit. And you can actually, if you look very careful there, you'll see that it says 32-bit, 64-bit. So that's telling us that this particular installation media, which is just a thumb drive by the way, if I plug this into a system to install Windows, if it sees I got a 64-bit processor, boom, it'll just go ahead and install it. 64-bit gives us a lot of advantages. The biggest one is more memory. And that's really in and of itself enough for us to want to install it. 4 gigabytes of memory on a system today is pretty small, but it can still happen. So now the question is, okay, I don't know what I have on my computer. How can I tell? Every operating system will let you know what version of operating system you have on it via 32-bit or 64-bit. If you take a look at the screen right here, here in Windows, if you take a look right here, it says system type, 64-bit operating system, and it's an x64-based processor. When we talk about processor types, when you see the term x86, that means it's a 32-bit processor. When you see that means it's a 64-bit processor. So it's easy enough to be able to quickly recognize whether you have a 64-bit version of Windows or a 32-bit version of Windows. So now the big problem that comes into play are the actual applications, because if you've got a 64-bit version of Windows, you probably want a 64-bit version of a particular application. So when we're dealing with applications, take a look on this screen right here. This is CPU-Z, and you'll see that when I download it, it downloads both a 32-bit and a 64-bit version. And here's some other utilities, and you'll see they all do 32-bit and 64-bit versions. If you had a 32-bit operating system and you installed, or at least tried to install a 64-bit application, you're not going to break anything. The installation's simply going to go, this isn't going to happen, and it stops you. So there's no damage in trying. However, in the opposite direction, it will work. For example, if you have a 64-bit version of Windows, you can install 32-bit applications. So Windows is actually designed to handle this. If you take a look in Windows on the C drive right here, you'll see you have two folders. This folder called Program Files, this is for 64-bit programs. This folder here called Program Files x86, remember x86 means 32-bit, will actually install 32-bit programs. If you install a 32-bit program on a 64-bit system, that application cannot use more than 4 gigabytes of RAM. So, for example, this happens all the time. In Office 365, for example, here I got Office 365 running. Okay, there's my account. But if you take a look right here, you'll see right up here it installed a 32-bit version of Word. This one had me scratching my head a little bit. I was like, all of these programs should be able to install the 64-bit version if I've got a 64-bit processor. And the answer, I actually had to look this up, came from Microsoft, and Microsoft said, we feel that the 32-bit version is better for compatibility. Like people have add-ons in their Excel spreadsheets and stuff like that, and that for compatibility reasons, Microsoft by default installed a 32-bit version of Office, even though I have a 64-bit processor. In fact, to install 64-bit Office, I had to dig a little bit to actually find the 64-bit installation. So, this is the big difference between 32-bit and 64-bit. If the world is all 64-bit, then why were we even talking about 32-bit, Mike? Is this ancient taters? Well, it's not. 32-bit is alive and well in a lot of systems, so there's absolutely nothing wrong with 32-bit. Just keep in mind that in today's world, it's a little bit more specialized, and you're going to be seeing it more on individual systems than on the regular big desktops and laptops and even most of the smartphones we use today. There's an old adage that says you can't be too rich or too thin. Now, I may not totally agree with that, but I'll put a corollary to it, and I'm going to say you can't have too much RAM in a computer. Everything you do on your computer counts on your RAM. Every active program that's running needs RAM in order to have the workspace it needs to do what it needs to do. Now, if you run out of RAM, you can run into a big problem. Let me show you what I'm talking about using a beaker I've got over here. Here's a graduated beaker. Now this beaker is going to represent all of the memory, all the RAM in my computer. So you'll see I've got it graduated from 0 up to 16 gigabytes because, well, that's how much memory I have in my PC. Now when I boot that computer up, some of this is going to be used for the operating system itself. So in Windows it's usually around 2 gigs. Now as we begin to load more and more programs, they begin to take up more and more space in this beaker. So some programs are fairly small, whereas other programs can be extreme. This is some big graphics program or something like that, taking up a lot of space. Now what you're looking at here is over time, as we begin to load more and more programs, we are suddenly in a position where we're about to use all of the memory. And if we use all the memory, you get one simple error called out of memory. And when that happens, your computer says, we're not going to go any further. So we really want to avoid out of memory errors. Now, in order to do that, we've got a little trick we can do. And this trick is to take a little bit of our hard drive and make it look, act, bark, smell, taste, and think that it's RAM. I know it's crazy, but it works. And we call this virtual memory. Now, every operating system has the virtual memory feature. And the thing I want to stress to you is we don't want to use virtual memory. We want to have enough RAM in our computers. Virtual memory is that thing we use every now and then and we're like, whoa, I'm using virtual memory. I've got a problem. I need to add more RAM. So virtual memory, although it's built into every operating system, it's not something we want to use. It's something that just keeps us running until we can open the system up and snap some more sticks in there. So what I'm going to use is Windows to take a look, and we can actually look at our virtual memory. So let's go ahead and do that right now. So in Windows, I can go over into my System Properties, and I go into Advanced Settings. UAC doesn't like me to do that. Over here in Advanced, and I click right here on Settings. This is Windows 10, by the way, and hit Advanced again. That was what, like 3 advanced in a row? Anyway, you get this screen right here, and it says Virtual Memory. So right now it has about 64 gigabytes set aside as virtual memory. That seems big, but this is what Microsoft likes. So let's hit Change, and what you'll see up here, this is the important one. In fact, you're going to see this on the exam too, and that is Automatically Manage Paging File. Paging file is the actual part of the hard drive that thinks it's RAM, automatically manage paging file size for all drives. In the Windows 10 world, we set that to automatic. If for some bizarre reason you wanted to manually configure this, you could. However, the days of manual configuration of these files is long over. So he's like, okay, so let's just cancel all that. And we're just going to go ahead and leave him automatic. What we have now is this paging file, this chunk of our hard drive that thinks it's RAM, ready to go. It's not an easy thing to find, but it's actually on our computer. It's on every operating system, but in Windows, I can actually take it and we can take a little look at it. So I'm going to open up a command prompt. If you're not familiar with command prompts, we've got lots of episodes in this series that cover it. And what I'm going to go is to the actual, what we call the root directory of the C drive, and I'm going to use a special command called dir. And this dir command, I'm going to put this little thing on the end that says, show me everything that has the attribute of hidden. So I want to see anything that we couldn't normally see. And if you take a look right here, do you see this guy? Where it says swapfile.sys. And this is a pretty big file right now, but it's nowhere near as big as we saw in the settings. It's a lot smaller than that. The reason is Microsoft is not going to take 64 gigabytes of your hard drive and set it aside for your swap file. It starts very small. In this case, it's about 1/4 of a gigabyte, but it can go ahead and grow up to that large if necessary. You don't want to use this. The alternative to not having a swap file is that your system's going to hopefully just give you a scary error screen and not work. It could also even freeze up your computer. The trick is this. If you start using virtual memory, and by the way, be careful with terminology here. You'll see people going, oh, I'm using the swap file. What it means is they're using virtual memory. Whenever you run into these types of scenarios, it's pretty painfully obvious. Number one, your computer slows way down because now your CPU, instead of writing to RAM, is trying to write to a spot on the hard drive. And all of a sudden, if you've got a desktop system or a lot of laptops that has a little light that shows you that your hard drive is active, that thing starts going nuts. That's a clue that you're using virtual memory. The way you fix this is to simply add more RAM. Trust me, it's a lot easier than it used to be in the old days where we would try to configure these things and play with it. Today, you have this virtual memory, you start to slow down a lot, and the fix is simple. Just add some RAM. There is nothing that makes me more crazy insane than watch somebody go to a computer store, buy some new high-end motherboard, some beautiful new CPU, fancy cooling system, really high-end RAM, beautiful case, huge monitor, flashy lights, keyboard and mouse, and they've spent X gazillions of dollars, and now it's sticker shock time. And then the last thing everybody buys is power protection. And that's the one place where everybody goes really cheap. So they end up spending, I don't know, let's take it over the top, thousands of dollars on a big high-end system, and then they suddenly decide to become cheap and they buy a piece of junk power protection. So in this episode, we're going to talk about the type of power protection you need for your systems. But before we get into the power protection, let's talk about what the problems are with power. And that comes from what we call spikes and sags. If you look at the power over time that's coming from the power company, in a perfect world, what it generates is this beautiful sine wave. So 60 times a second, it goes from one point, it makes a peak, it makes a valley, and then comes back to the 0 point. So that is 1 hertz. So 60 times a second here in the States, that's what takes place. In reality, electricity is a tricky thing to get in good order from a power company. So one of the things that will often take place is that it won't go all the way up to 120 volts in one direction either way. It'll start doing stuff like this. In this case, you're never getting 120 volts. At best, you might be getting 60 volts or something like that. It's not zero. You are getting electricity, but the power company, a transformer goes out or something takes place, and suddenly you are getting what we call a sag. Sometimes you'll hear the term brownout. That means you're not getting enough voltage. This can keep your computer from running and can cause reboots. Far more dangerous, however, is this. There are situations where instead of getting 120 volts here in the States, you might suddenly get 300 volts in the States. And then it'll come back down, act normal for a minute, and then boom, another one. These are called spikes. Spikes is when you're suddenly provided far more voltage than what you're expecting. Spikes are dangerous because they can literally destroy your computer. Spikes are also known as surges. So a spike and a surge is the same thing. A sag and a brownout is the same thing. Okay, so sags and brownouts are not a happy thing. It might make our computer reboot. A spike or a surge can destroy your system. So at the very least, we're always going to try to find some device that's going to be a surge suppressor, a surge protector. They go by a lot of different names. Their job is to catch those big spikes of voltage and just basically eat them in themselves so that it doesn't carry it onward into your system itself. There's lots of them out here. I've got an example right here. Now, this surge suppressor is pretty typical. There's a few things I want to mention though when we talk about surge suppressors. First of all, I always like to have one with, well, if I can get it, an on-off switch, because I like to know that it's actually on, and secondly, a trip alert, or it can be one simple button that does both. All of a sudden it's on and it goes off all of a sudden. The reason I like that is because, yes, it's inconvenient to have my computer suddenly turn off. However, certain power companies are notorious for bad electricity. Now, I'm not going to name any names, Houston, but there are certain cities here in the U.S. that just are a little bit notorious for not giving us that beautiful sine wave voltage that we like. And I want to know that there is a problem like that. Yes, it's great that it absorbs the spikes, it absorbs those surges, but I also want to know it's happening. So that's where I'm willing to let the thing kick off so that I can notice that that's taking place. So while we're talking about surge suppressors, they don't just stop in terms of what you can plug into them. You can get surge suppressors that will protect your Ethernet cabling. You can have, if you're actually still using it, you can find surge suppressors that protect landlines for telephone. Yeah, I still got one, why not? But even things like USB, a lot of us love to charge our USB devices. We use those little AC adapters. So it's convenient if I have something I could just plug my USB into. Why not have something I can plug my USB into and at the same time prevent those surges from destroying my beautiful thumb drives or any other USB device I might choose to be charging at any given moment. So they're great. Don't worry about UL ratings or any official government body ratings. They used to be pretty common with surge suppressors, but today they're all so good that pretty much what they'll do is a big company will go out to some independent laboratory that's not a government agency and hand you a piece of paper. That's about anything that's good for it anymore. The only downside to cheap surge suppressors is that a cheap one will be a good surge suppressor one time, and then it turns into a power strip. So again, that's why I like to know when things are tripping. And also for me, if I'm paying less than, well, here in the US, about $25 to $30 for a surge suppressor, I'm probably getting one that will only work well one time. Now, if you really want to do things right, what you want to go to is a beastie like this. What you're looking at here is an uninterruptible power supply, or UPS. UPSs protect not only from spikes and surges, they help protect you from sags and brownouts. Now think about this for a minute. How would it do that? In order to do that, it would have to make electricity. If things don't give you enough, somebody's going to have to pour some electricity in. And that's because inside every one of these guys is some kind of, well, traditionally they were motorcycle batteries, although the industry today makes their own special batteries for UPSs. These batteries pick up whatever your power company doesn't provide. So they're batteries, so they have a certain amount of time that they can do stuff depending on how much you're pulling off of them. So when we buy these different types of UPSs, what we're going to do, first of all, no one's going to test you on how long does a UPS last, because no one can answer that question because we don't know how much your system's pulling. But there's a few things that we can talk about. In general, one of the big things is if you take a look on the top of this system right here, you're going to see that one side of this is, it says battery backup, surge protection. This is the only plugs on this system that actually provide protection against sags and brownouts. Over here, this is just a surge protector. So number one, you want to make sure you know where you're plugging them in. Many UPS makers provide a software interface between your UPS and your system that allows you to monitor it. So here's a screenshot of an example of this. So you can see it can tell you how many minutes of reserve power is in the battery right now, and that can often be a very convenient tool to give you an idea of how well your UPS is working. All of these companies, I've got APC brand here in front of you, which I like APC quite a bit. When I'm going to buy myself a UPS, I'm going to go onto the APS website and it's going to talk about how much time, and it's usually measured in minutes. This is not hours. The idea is that you lose power and then all of a sudden you have 15 minutes, 20 minutes, on a really nice one, maybe 30 minutes, where you can actually power the system down. So you don't look at these things as, oh, we've lost power because of a hurricane, so I'm just going to keep running. No, it gives you enough time to shut the machine down in a pretty way. If you want to have something that's going to survive when you've lost power for hours, now you're talking about backup generator systems or something like that, which will provide power. So don't confuse those. In my opinion, about the only thing that I'm going to use simply a surge protector for anymore is going to be really inexpensive stuff. For example, I've got some flatbed scanners that cost me 80 bucks each and a couple of cheap printers. Those I might put on a surge protector. Almost any other system that I use today, I have UPS for. I'm talking about in my house, I'm talking about in the office, I'm talking about in the server room. In today's world, UPSs are powerful, reliable, they work great, and why bother protecting just from surges and spikes when you can protect from sags and brownouts just as well with the same box?